Hello world, welcome back to another Flash Learn devlog where I'm developing a Gen AI powered flashcard system like Anki. Let's start off with a quick summary of what I did this week. The focus of this week has been on migrations. I had to manually write a lot of SQL code before, but now I'm using sqlc for type-safe SQL code generation. This has made my life so much easier. And on the UI end, I moved from having everything, all my spaghetti code in my UI code, and moved to adapting MVVM, which is short for model view and view model architecture. And I also Dockerized my entire application with Docker and Docker Compose, which makes running that thing much simple. I just have to run just a simple command. And finally, I also managed to implement two features, which are adding cards to decks and browsing all the cards added to those decks as well. Alright, let's start things off with sqlc, which is a SQL code generation supporting multiple different languages, including the language that I'm using for my backend, which is Go. And the reason why I'm using this is because writing SQL in Go has been a nightmare. Like, look at this. I had to use string builders, I had to use constants wherever I could, and then string these all together. And then if I wanted to change anything, yeah, it's gonna be like a huge mess to change this. I wouldn't even know what I've written here after coming back a couple of days later. So it's gonna be creating a lot of bugs. Instead, what I could do is just write the schema in normal SQL language, which is right over here. Look at the difference. I could even read this properly and then find any bugs if I had to. And all I had to do was write this schema and then write all the queries that I need, and then just say sqlc.generate, and all the code, the type-safe code, is generated for me. So if I go to query over here, so I just have to call create card table, and then this will be executed for me. All of this, like all three of these files, are generated by sqlc. I don't have to do anything. So say that I wanted to do any changes. Previously, I had to come here and then make sense out of all this mess and then change something over here. Now, I don't have to do any of that. I just have to come here, change, hit generate, and then all of this is generated for me. The next biggest improvement to my project is shifting from having all my spaghetti code in one freaking file to adapting MVVM, or model view model architecture. Before I tell you what MVVM is, let me show you what my code previously used to look like. This is my homepage code. It isn't too big, but it's just small enough and has just enough issues for me to show you why I had to switch. This has everything in it: UI code, business logic, state management logic, data fetching, everything. As you can see here, it's doing the navigation over here, then trying to manage the state, trying to fetch the data, and then even trying to show the data, or how to show the data properly. What's the problem? It's not too big of a file. Well, currently it isn't, but this is like a very simple home page. All it's doing is, if you come over here, all it's doing is you're getting the decks, you have a button over here, and then you have some links over here. That's it. It's not very complex. But when things do get complex, and they will, when I click on browse, you see there's a lot of things going on over here. When things get very, very complicated, this is not gonna work out, and it's very hard to test as well because everything is grouped into one huge file. So I adapted MVVM. The M in MVVM stands for model. So basically, any portion of your code that is responsible for data fetching or data processing or anything to do with data, it's going to be in the models folder. So the next part is view. So view is basically your UI code. So how are you going to show? View model is basically the business logic. So after you get the data, what are you going to do with it? And then how are you going to show it? So let's look at the homepage after all of this. It's less than 30 lines of code. All of it is related to only UI elements. So it makes things much easier to test. As you can see, I can mock most of the stuff out, and I can just focus on testing whether everything is over here. So I'm going to test whether the buttons are here, whether the app stuff is over here, and so on. What does homepage view model have? Well, it has the state management, the navigation, data fetching, and so on. It also handles the error catching as well. So it first calls the data fetcher, which is basically handling all data fetching needs. and then once it has the data, it's going to try and set it. If there's an error, it's going to catch it and then set the error state. And finally, it's going to set loading to be false. The data is being kept at deck model. And then if I need to do any processing or parsing or anything, I'll also do this in the deck model itself. All right, so I'm going to talk about the features that I worked on this week. Mainly, I did two features, that is add card and viewing card. First off is add card. As you can see here, I have an Anki add card window open. So the interesting part of this card form is the tag option over here. So if I type in, I don't know, COM, it's going to show me some suggestions of previously entered tags. And if I click on them, it's shown as a badge over here. And I can also click on this delete button icon and then it gets deleted as well. I've tried to follow a similar design philosophy in my case as well. So if I type on a deck and I click on the add card button over here, I have an almost identical layout with tags over here. If I type in time, you get time complexity because I entered a card previously with this tag, and you can add it. If I want to type in something else, let's just say computer or something like that, and then press comma, it automatically gets added over here. Yeah, so I can click on the cross button and it gets removed. Let's just do like a demo insert, test front, test back, test source, and then time complexity, click on submit, and cards get added successfully. Yeah, so I adapted the same thing to my Chrome extension over here. You can see the source, which is fetched from the tab address, and this cannot be changed. And then we have the front, back, and the deck is basically going to be where you want to store it. And you have the tags over here. It functions exactly the same way as the tags on the web browser. So if I type in C, you'll see here it's CS time complexity, just like over here. And the cards added to the Chrome extension and the website are both to the same database. So if you add something using the Chrome extension, it will show up here in the browser, which brings me to the browser tab. And this is where I can see all the cards that I have ever created all in one place called the browse tab. But don't worry, not all of it is fetched all at once. I do use pagination so that it's loaded in chunks. Let's do search. Let's say O and then this. And then search. So here you can see that the two cards that actually have that actually show up. The next thing I'm going to show you is the sorting. So if I click on deck, it first sorts by ascending order. Then if I click it again, by descending order. And if I wanted to do more sorting, like if I click on content, since I don't have much cards, nothing really changed, but you can do that as well. So what does the number mean? The number means first sort by deck in descending order, then sort by content in ascending order. And yeah, so the sorting works, the searching works. The next thing that I want to do is filtering. Right now I can only do text matching, but in the future, something like saying tag :CS will fetch all the tags that have CS in them, or maybe deck : compute comp will match the deck column over here. Right now the text only matches the content column. So let's now dive a little bit deeper into how I'm handling that browsing section. So I fetch my data using this get/view URL, and if I go into the function that's actually implementing it, that's right over here. And these are all the different types of parameters that I currently support. There is limit, offset. So limit and offset are used for pagination purposes. The search term is basically used for the search box, and then we have a lot of sorting parameters. Each column can be sorted in two ways. So there is ascending and then descending. And the reason I've implemented it this way is because I couldn't find another workaround for doing this in SQL, which is done this way. So basically this looks like a huge SQL chunk, but let me explain how it works. These are all the normal select and from, where is basically used for filtering the search parameters. Here in case, basically what this is doing is it's checking, hey, is order by deck name ascending provided? If it is, then return deck.name in ascending order. And then it does the same thing, but checks for descending of deck name. And since we have 4 and multiply that by 2, we have 8 different case and when statements. This is the only way that I've found that this could work. If any of you knew a better way of doing this, please let me know. You might be asking, what if both of them are true? So ascending and descending are both provided for the same column. How would you do it? Wouldn't that be an issue? Well, not really, because I actually thought about it and did some checking over here. So if both ascending and descending is true for any of the same columns, I just return a bad status request. For now, it is pretty simple, but this function is going to get even larger when I'm adding multiple filtering and other types of querying. So that wraps up this week's devlog of FlashLearn. Hopefully you guys enjoyed it, because I had a lot of fun developing for the application. And next week I'm going to be working on developing the filtering options for browse page, the edit form for card editing, and maybe even get started on the study mechanism. So if you like what you see and you want more, look forward to new videos. Until then, catch you guys in the next one.